So till now we have covered the basic regression algorithms, multiple linear regression, in regression, and binary logistic regression and classification. And then we moved on to the tree-based models. In the tree-based models, we have done the single tree model, which is the decision tree. And then we moved into the ensemble methods, which is the multi-tree model. Within multi-tree models, ensemble methods, we have talked about the first method called bagging. Bagging is also called as bootstrap aggregating. Today, we will discuss the second type of ensemble methods. So multi-tree models, ensemble methods. The second type of method is boosting. The first method is bagging, bootstrap aggregating. The popular algorithm in bagging is random forest, which we have discussed in the previous sessions. Random forest regression and random forest classifier. The second type of ensemble method, which is called as boosting. And the popular algorithm in boosting is gradient boosting machine, also called as GBM, gradient boosting machine, GBM. Now, this is also a CART model. This works both for regression and classification. This works both as a regression model as well as a classification model. Gradient boosting machines, GBMs. Now, they have GBM is created, or let us say GBM is developed with a focus on weak learners or misclassified observations. The objective of this algorithm is to increase accuracy and lower RMSE by targeting the wrong predictions and pushing them towards correct predictions. So gradient boosting machines are set of is an algorithm developed by the statisticians with a focus on wrong predictions or weak learners. In some instances, these wrong predictions will be in critical class. If you are studying some particular set of class, or if you are trying to study a particular set of observations, these wrong predictions or misclassifications will create problem. Boosting algorithms. The word boosting here refers to boosting the weak learners or wrong predictions towards the right predictions. That is the concept of boosting. Now, how this boosting is done? By giving more weightage to these wrong predictions and passing them through multiple trees. So, how this boosting works is, boosting adds more weightages to weak learners and pass them through multiple trees so that the chances of correct predictions increase. This is the concept of boosting. See, the fundamental concept of bagging is sampling method. If you are looking at random forest algorithm, everything depends on the sampling, or we call it as the bootstrap processing. The sampling method which is employed in random forest, we call it as bootstrap sampling or sampling with replacement, where observations appear in multiple samples, thereby in multiple trees, and thereby their chances of predictions will increase higher. Their chances of prediction will be higher, correct predictions would be higher. That is the concept of bagging. Boosting, on the other hand, targets the weak learners. They focus mostly on the weak learners. They push these weak learners or the wrong classifiers into the samples and add weightages to the samples. They add weight to these wrong predictions into the sample, and they give more preferential weightage when they are being built into the trees. So thereby, the chances of its correct prediction will increase. The boost which this algorithm gives to the weak learners is expected to push them from wrong predictions to right predictions. That is the concept here employed by the boosting algorithms. These boosting algorithms are developed to work on weak learners or misclassifiers or wrong predictions. For some specific problems, these weak learners and misclassifiers will create more problems. So the weak learners which create more problems are, if you are doing fraud analysis or credit default or loan default analysis, you will have a lot of issues if they are being wrongly classified. So we need to focus on these wrong predictions in certain business problems. So for that purpose, these boosting algorithms are developed. Okay. Steps in the GBM, gradient boosting. Step 1, specify the number of trees to be built, which is n underscore estimator is equal to 500. Specified number of trees to be built. So we are asking it to build 500 trees. Step 2, create sample 1, which contains 65% of randomly selected rows or observations and square root of number of variables. Okay, sample 1 will be created. 65% of the rows and square root of number of variables randomly selected. Now, step 3. Build a decision tree for sample 1 and also predict. Step 4, identify the wrong predictions or weak learners and move them to sample 2. So the wrong predictions or weak learners are identified and they are moved to sample 2. Step 5, replenish sample 2. That means get the remaining data and complete sample 2. Step 6, build a decision tree for sample 2 and also predict. Step 7, identify wrong predictions and move them to sample 3 and so on. So this process will continue till you reach the 500 trees. So here each tree is dependent on previous trees per sampling, per sample. It is a sequential building method. Bagging is a parallel processing method. Boosting is a sequential method, because until first tree is built, you will not have the second sample for second tree. Until tree 2 is built, you cannot have sample for tree 3, because the sample is primarily coming from the wrong predictions of the previous trees. The sample predominantly comes from the wrong predictions or weak learners from the previous trees. So that this is a sequential method, whereas bagging is parallel method, because each sample is independent. In bagging, first sampling is completed, then the tree building will start. Here it is not like that. One tree is completed, then only you can go to the second tree. Second tree is completed, then only you can go to the third tree. Third tree completed, you go to the fourth tree. Sequential building of trees. Boosting algorithms have comparatively slightly higher accuracy than bagging trees. Boosting algorithms have higher accuracy or lower RMSE compared to the bagging tree, which is your random forest. So the trees are built here also. The computational requirement is not that intense, because first you build tree by tree. It's not parallel building of the tree. So we know computing power requirement is not that much compared to the random forest, but these models also require certain amount of computing power. So boosting methods are very popular in data science competitions because they have higher accuracy compared to any other model. They give you a lot of accuracy, a lot of what you call advantage in data science competitions. So this is the basic concept of boosting. Now, when you look at boosting, gradient boosting, there are very popular extended versions of gradient boosting. There are popular methods of gradient boosting, which you are familiar. I think in Python we have them. I think Python we don't have them. Okay. So one of the popular method of boosting algorithm, which is very popular in data science, is extreme gradient boosting, also called as XGBoost. There are variants. One is the extreme gradient boosting. also called as XGBoost. Then light gradient boosting, LGBM. Then you have cat boost for categorical data. So there are variants of GBM which are available, which play a very important role in data science competitions. XGBoost, light boosting, cat boost. So these are the popular variants of gradient boosting. And one of the old algorithm which is still used in some parts of data science is AdaBoost. Apart from gradient boosting, the other algorithm is AdaBoost, which is adaptive boosting, which is a very old data mining based algorithm. But nowadays, the popular algorithm is gradient boosting. GBM or gradient boosting machine is the popular algorithm. GBMs are very popular in data science. They have comparatively higher accuracy compared to the random forest in some instances. But their performance is also good in competitions. There is ensemble methods. So gradient boosting decision trees. Gradient boosting decision trees. Here also one of the parameters is controlling the tree size, max depth. Max depth is very important here. So this is the mathematical formulation of the GBM, regression and classification. So gradient boosting is a very popular algorithm. And apart from GBMs, we are XGBoost versus gradient boosting. See, this is the thing here, what you call the first tree and the predicted tree. The predicted tree. The predicted tree goes into the sample two, and then new predictions will generate, and that also adds to it, and then it will create a new model. So this is how the GBMs work. So the primary difference between these trees are the symmetric trees and asymmetric trees. Symmetric trees and asymmetric trees are the primary difference between the variants. Difference between variants is symmetric trees and asymmetric trees. So that is the first thing. Symmetric trees, the splitting condition must result in the lowest loss across all nodes of same depth. So the symmetric trees means the splitting condition must result in the lowest loss across all nodes of the same depth. So the loss or the error of each depth must be constant in symmetric trees. Symmetric trees, they expect the loss at each level of or at each depth to be to be same. Now, the important thing you also need to understand is the asymmetric tree. Now, in asymmetric trees, the splitting condition for each node will differ. The splitting condition for each node will differ. In the asymmetric trees, across the same depth, you will have different nodes. In this, first we will look at the symmetric and asymmetric trees. See, what do you observe here? Condition A. The node is condition B only on two sides. Right? In asymmetric trees, this is condition B and condition C. That means you have different parameters in asymmetric trees where you have same parameter in the level or depth. We call it depth, na? Level or depth in the same condition will be there in the level or the depth. Whereas the conditions will differ, or in this case, when I say condition, the variables greater than equal to, right? You remember how we define the conditions using the greater than equal to logical test. One side yes, the other side no, and then we build the tree. So in symmetric trees, the condition will be the same on both the sides, whereas in asymmetric trees, the conditions differ on each side. That is the difference between symmetric tree and asymmetric tree. Now, if you look at these things, the symmetric trees and all, CatBoost uses symmetric trees. CatBoost is symmetric tree, categorical boosting. CatBoost uses symmetric trees, and the other two, the LightGBM and XGBoost, use asymmetric trees. Use asymmetric trees. This table also is important. I am putting this table also here. because you guys will be using in hackathons and competitions these only. These algorithms have a higher accuracy in competitions, and most of the time, the leaders in the competition, top 10% will be using a combination of these three algorithms: XGBoost, LightBoost, and CatBoost, depending upon the type of data. If your data has a lot of categorical variables, they use CatBoost. So you can see here from the table, see here, categorical columns is very critical in here. So CatBoost, you have to perform one hot encoding. Now I forgot to talk about two more encoding. One hot encoding I forgot. We have talked about get dummies. We have talked about label encoding. One hot encoding is similar to get dummies. One hot encoding is similar to get dummies. Get dummies will create separate columns, right? One hot encoding will also create separate columns, but converts the data into an array, not into a data frame. Data frames means you have different columns. Array means everything in one single column. The primary difference between one hot encoding and get dummies is, in get dummies you have separate column and you do 0-1 encoding. Same thing happens in one hot encoding, but the data structure changes from data frame to NumPy array. NumPy array fits into one single column. All the variables will be fit into one single column. That process we call it as one hot encoding. One hot encoding is similar to pd.getDummies, but in pd.getDummies we will retain the data frame structure, whereas in one hot encoding the data structure changes from data frame to array. Array means square brackets and the elements, and they will be into one single column. So for categorical boosting, one hot encoding must be done. Okay, and even for XGBoost, we prefer one hot encoding, but the label encoding also will work. LightGBM label encoding will work. So all three handle missing values. All three of them have internal system built for handling missing values. You can specify the strategy, missing value strategy, in the function itself. So it will automatically impute the missing values, and thereby it will run the algorithm. So these are three popular variants of GBMs: gradient boosting machines. Boosting machines predominantly target the weak learners or wrong predictions. They were designed to work on weak learners or wrong predictions. So in XGBoost, they give more weightages. In LightGBM, the weightage is to a sort of weighted similar average. In categorical boost, it is done on categorical variables. So in XGBoost, large weightages are given to the wrong predictions. Big weightages are given to the thing. So if I show you the XGBoost weightage thing, you will be able to understand here. So this is our original data sets where you have minuses and plus. Okay, then a classifier is drawn like this. Now, when you draw a classifier like this, the plus is getting misclassified here, right? Once you have done the classification, you can see the plus is getting wrongly classified into minuses. So in the next iteration, the data set, see the size of the plus? The size of the plus will increase. And there are also two minuses which are wrongly classified. On the plus side, there are two minuses which are wrongly classified. And look at the size of the minuses, they are also given bigger. The hyphen size increased, right? Weightage is given, and then there a new classifier is built. Now, once the classifier is built, all the plus signs are being correctly predicted, but the three minuses are wrongly predicted. Now, these three minuses are given more weightages in the next iteration. And then finally, it draws a line like this, where you have wrong predictions of, I think plus is coming out totally. So if you add all these four lines, you will get the predictions like this. So all the blues are on this side, all the reds are onto the side. This is a hyperplane prediction, but in reality, it will be a optimal plane prediction. It's not just for our explanation, it is giving the hyperplane, that means a flat surface based prediction, but in reality, it is a non-linear predictions, which we get is a not a flat surface, it will be a non-linear dimensional prediction. So this is how the XGBoost algorithm works. Adding weightages, more weightages to the wrong predictions and hoping they will be rightly classified. So the XGBoost algorithm you can see the XGBoost algorithm, how it works. Now, these are why I'm focusing this, because in hackathons, you have to use them. In hackathons or in competitions, ultimately, you have to use these boosting algorithms for getting the highest level accuracies. But in real-time data science, we will not go for accuracy, we will go for consistency. There are two things, hackathons and competitions, highest accuracy, 99%, even though it is overfitting, it will give you winning. But in real-time data science, we go for consistency. Consistency means the model will have lesser accuracy, but still it will have good performance over different types of data. Consistency is more important in real-time data science. Your models need not have 95% accuracy or have lowest RMSE. There must be some RMSE still there. There will be lesser accuracy within the range of 0.70 to 0.95. But if it is performing well on cross validations on test data, you must be happy with it. So you need to understand one thing, that hackathons and competitions is one thing, real-time data science is another thing. In real-time data science, we always look for lower accuracy but consistent accuracy. We will are happy with 80% accuracy as long as cross validation also gives us 80% accuracy. As long as the test data also gives us closer to similar accuracy, we will not have any problem. We'll implement the model and we will go for production and we will be happy with it. But in competitions, until unless you overfit, you will not win the competition, right? 99% accuracies, 100% accuracies, or RMS is closer to 0 is what your competitions will win. So competitions and hackathons are different scenarios and your real-time data science are different. But in real-time data science, you always go for a consistent model. Consistency is more important than going for higher accuracies. All right. Any doubts in boostings? Boosting algorithms. Generally, until unless you say you are expert in boosting, please don't mention it as your algorithm, because this is a little bit complicated to explain. And they will definitely ask you about the variants. What is XGBoost? What is light boost? So until unless you are 100% confident, don't tell the recruiter that you are confident with this algorithm. Stick to MLR, logistic regression, decision tree. You can go to the higher end algorithms as long as you are able to explain to the recruiter in your simple terms. And when you go to this boosting, the complications are, they will definitely ask you what is XGBoost, LightGBoost, and CATBoost, and what are their differences. So I would suggest avoid GBeams. Random forest would be a better algorithm because it doesn't have much of a complication where you can easily explain it to the recruiter. Okay, you might work on them later, but when you're going through an interview process, the criteria is how well you are explaining it to the recruiter. The recruiter must understand what you are explaining. If you can't understand, then it will be a problem for you, which happened with some PJ16 guys. They made some blunders in explaining some basic concepts. That's what the recruiters told us. So please don't make those blunders in explaining those concepts. One person was talking about classification when the recruiter asked him about regression question. That's an absolute blunder, right? Regression and classification are two different things. And the same person also argued with the recruiter saying that classification and clusters are same. They are not same. Clustering is a segmentation technique. Classification is a different technique. It's a completely different techniques. You can't say both are same. Segmentation is a grouping technique. It groups based on similarity. Classification is an algorithm based that uses probability for classification. Okay. Any other doubts you have? Okay, just log into LMS. See what data they have given for. We'll work on some new data, or we'll work on the existing data only. I think we'll implement this on existing data, and then post break we'll work on some new data. Just check your LMS. So you have submitted in the analytics with the competition, right? Random forest also submitted, or Big Mart sales you have submitted to competition. On BigMart, you have implemented random forest, right? On BigMart, did you implement random forest? Yeah, we have implemented on BigFort random forest regressor in the last session. Okay, open that BigMart notebook and run all the cells. We talked about cross validation also, right? In the previous session, just open that notebook, run all the cells. BigMart notebook. So I'm predicting it on the random forest model. RF predict dot two underscore CSV RF dot CSV. We are predicting on the test data. We have also predicted on the decision tree data, right? Okay. So let me see what is the accuracy levels I got. AV Big Mart sales. Where is that one? Excel. Submission. Excel. Okay. So this is the decision tree prediction. Control C, Control V, Control S. Okay. Then I will go to the competition site. Analytics Vidya Big Mart sales. Solution checker, upload file. Desktop, hackathon, Big Mart sales, sample submission, open. Efficient, add solution. See, for decision tree, the RMSE is 1163. I'll copy the decision tree RMSE into our notebook. Decision tree, the RMSE is this. Model RMSE competition site. Okay. So I have submitted decision tree, I got 1163. Now I will submit random forest. Open with Excel. I got the random forest. Control C. Go to the sample submission file. Control V. Control S. Close. Close. Now I'll go back to the competition site. Close. Upload solution file. Sample submission. This is random forest. No. Add solution. Oh, slight improvement. 1158 5106. Random forest. I got 1158 5106. So you have to submit it onto the sites and get the competition scores and understand algorithms, how these algorithms work upon. Okay. So all of you do these predictions. Once you are done, please confirm. Random forest. Decision tree, we tree predict, na? We have done that day. Here. Here. See? Tree model.predict on Big Mart test data set, and we have saved it as tree predict.csv. Got it, all of you? The random forest and the decision tree for big mart sales. My previous submission of random forest was better, I think. Same 115 at only. Yeah? Mm. Right? For which one? How much you got? Random forest is random sampling, right? Your sampling will be different from my sampling. Random sampling will be different, no? Until we set up a random state. If you set a seed, let us say there is an option called random underscore state. If you all say random underscore state is equal to 1 to 3, then all of us will get the same answer. Otherwise, each of us will get, none of the two people will answer will match, because random is completely random sampling, right? So, but it will not be that great difference. How much difference you got? Well, if you run it again, it will come down slightly. If you run it again, for you also it will change. Because are your parameters same? Max depth 8, 2000 estimators. No, 2000 estimators. Make it 2000 estimators. Make it 2000 estimators and max depth as 8 for the random forest. 1400 for what? For both? Precision max depth 6. Hello. Yes. Yeah. Okay, all of you got this? Okay. From sklearn dot ensemble import gradient boosting regressor GBM gradient boosting regressor n underscore estimators is equal to 2000. GBM GBM model is equal to GBM dot fit x comma y. Got it corrected? That thing. X, maybe you have taken label and coded X. On gradient boosting model, I got 83. GBM predict is equal to GBM model dot predict Sigma test DF. GBM dot data frame GBM predict dot to underscore CSV GBM dot CSV. Gradient boosting regressor. Oh, negative values, sir. Very huge range. Huh? That's why it is saying wrong predictions are negative predictions are there. So we will do the max depth also. It's a very bad thing you got, right?
It's like 83 in score, but ideation is 52.
Ah. Oh, 8 depth, it is going up to 99.97. Again, there is a negative value. If negative values are there, we can't use it for prediction. Thousand. Get again negative values. GBM is not working because it is predicting negative values. Sales cannot be negative, right? See, minus 84. Minus 13. So GBM model is not working. Let us see where is the problem. So we are not able to predict using the gradient boosting because it is generating negative sales values. So negative sales values is a problem. Okay. Now, basic gradient boosting is predicting negative values, so we are not in a position to do a correct predictions. Now, let us see what is our XG boost gives. Port. We have to install XG boost. So you can open your command prompt or Anaconda prompt. I will open terminal. New window. Open your Anaconda prompt. In the Anaconda folder, you'll have Anaconda prompt. There, Conda install -c, Conda -forge XGBoost. So this is the command you have to install, the one in the blue. Anaconda prompt. You have opened Anaconda prompt in your Anaconda folder. Go to list of programs. You'll see Anaconda folder. In that you will see Anaconda prompt. And then you type this one in Anaconda prompt. Conda install space install -c space Conda -forge space XGBoost. And then press enter. It will solve the environment, and then you type Y, small y, and enter, it will start installing. Installed. Import XGBoost as XGB. Dmat is equal to as XGB dot dmatrix data is equal to X comma label is equal to Y. $84,055. I got 84,055 for XG post. XGB predict, XGB model dot predict, smart test DF, PD dot data frame, XGB predict dot two underscore CSV, XGB dot CSV. Let me see if XGB dot CSV works or not. Oh, this also has negative values, sir. XGB also gives you negative values. Okay, it is also giving negative sample, negative values. Till score we have done. Mhm.
So this XGB
Cross validation.
score value,
How much you got?
0.61.
Okay. Same you got XGB regressor only, right? Let us see, one day. Okay. Let us give some more arguments. Call underscore sample by tree is equal to 0.3 is equal to 0.1 comma underscore that is equal to 5 and underscore estimate. 0.1 comma 5 and underscore estimate. 5 and underscore estimate is equal to 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 5 and underscore estimate is equal equal to 100. One, seven, five. Negative values. So boosting algorithms are not working on this data because we're getting negative values. Negative predictions are coming despite giving the parameters and all, it still didn't work. So it is giving us negative values. Okay. So we'll stop here. You can take your break and we'll continue our session later. So we have predicted on logistic and decision tree. I think we have submitted them on competition site also. And then we got some scores. On this data, run random forest, gradient boosting. And we'll also submit the scores and see how much ranks will improve. Oh, we got an error on HR test DF. What is the problem with HR test DF? Okay, we have to remove that X thing. Yeah, shit. The problem was we have done random forest also. Okay. Hello. Yes. Yeah, yeah, tell me. I'm waiting for the travel thing. What was the travel arrangements that were made and all? Okay. Okay. I would prefer online lectures as of now because I think the corona cases are also increasing. So I'm looking at online lecture would be a better option for me because Bombay is reporting some corona cases and all. So I would go for an online lecture. So that would be better for all. The timings are okay with me, no problem. Or can it be done if it is online? If it can be done in one single day, that also is possible. I can do it. If not, okay. Or spread over 2 days is also fine with me. Hmm. Okay. Yeah. Yeah. Online lectures would be better option. Yeah. Hmm. Yeah. Hey, Wednesday and Thursday. Wednesday you will not have a class. Okay. So Wednesday, Thursday, I'm taking. Actually, I have to travel to Bombay because corona cases are increasing. So I made them online. So let me see what Wednesday. Guys are able to run? Yeah, so- because it's not like Why it is saying 4 features? The 4 features thing, where is it 4 features thing? Yeah, it worked. You checked your LMS, what was the data sets given there? Okay, data sets will be there here. So logistic, we got 0.11, decision tree 0.33. Random forest, we have not done the prediction. Show me your LMS. You have to complete those LMS data sets, otherwise you will not get your certificate. Just everybody log into your LMS. So I told him by evening it will be done. The course allotment has to be done by the Bombay guys. They will do it for you. Once you do it, you will get module wise decision tree, video, and the data set. Okay. So what you do is you do only that algorithm, not like this. If that data set says run decision tree, only run decision tree. You don't need to do all this pre-processing and all. I think only couple of data sets are missing values. Only those data sets you process. Rest of them, complete them. Once you complete those LMS thing, then only you will get your certificate course. So along these sessions, you have to complete the LMS also. So for random forest, RF predict. What are you are getting? Pink color. So what happens is in between we created a 4 variable thing to check our Excel thing. Delete those cells. I will show you 1 second. Hold on. So we have to check that Excel thing. Model. Sunny? Hello. Yeah, hello. Yes. Yes, yes, please. Hello. Yeah, I can hear you, ma'am. Good morning. Yeah, good, ma'am. You corrected the error? Zero 0.41 for random forest. Earlier it came 4259. Maybe in R I got that one. You got how much? 42. 42. How many trees you have given? Thousand, huh? Yeah. So you got 92 point something, closer only, right? 41, 42. Okay, no problem. On this run gradient boosting. Why you will get negative values here? Gradient boosting classifier, right? You are not using regressor, right? GBM will not, here there is no question of negative values. No, it's a probability based prediction system. Gradient boosting you're running? Given model dot score 94.49 medium predict equal to GBM model dot predict dot test df vd dot data frame GBM predict dot to underscore csv GBM dot csv. 48. Yes. See how GBM drastically improves. So you can make a summary. For logistic, we got very less because the imbalanced data. Now, when I talk about imbalanced data, we will discuss this issue. So logistic regression, the score was 0.1141. For decision tree, the score was 0.3350. For random forest, the score was 0.4106. Gradient boosting, the score is 0.4811. So this is the performance of our models. Very HR analytics. Submission scores. So as of now, the best fit model is gradient boosting at 0.48. Leaderboard is how much? 0.59. 54. We are almost closer to leaderboard. Without doing XGB matrix, we'll try to run XGBoost and see how it will improve. XGBoost you have done? Any increase? You're running, huh? Sure, SOP is no part of Vijayanagar University. Huh? Can XGBoost? How much is the acquisition? 47 only. How many estimators you have given? Import XGBoost as XGB. XGB underscore class is equal to XGB dot XGB classifier underscore estimators equal to 1000. XGB model is equal to XGB underscore class dot fit x comma y. What we have another warnings. The warnings we got. So the use of label encoder in XGB classifier is deprecated and will be removed in a future release. To remove this one, to pass option use label encoder is equal to false. When classifying XGB object, encode your labels as integers starting with 0. Binary logistic loss. So XGB model dot code x comma y 99.04, right? XGB predict is equal to XGB model dot predict HR test DF 3D dot data frame XGB predict dot to underscore CSP xgb.csv. Oh, let us see what is our xgb score. C, Control V, Control S. Chart analytics, solution checker, report file, sample submission, GBoost. 48.12. For gradient, you got how much? 48.11. So an estimate is 3,000. It reduced, huh? So that means the old version is good. By, so by increasing the number of trees, it doesn't work. XGB2. So we have to go with the old version only, 1001 only. So 48.12 is our highest score based on XGBoost. No, no, no. We are still finalizing our models. Once we have finalized your model, you have to convert it into a pickle. And then you have to use a deployment software like PyCharm. Model building. We are still not able to finalize our model. As of now, GBM looks the best fit model. But we have to try neural networks. We can try naive Bayes, other classification, support vector machines, KNN. So we have other algorithms to be done. So after all this, we'll get the best fit model. Then once you finalize your best fit model, then we will go and convert it into pickle, and then we will deploy it on PyCharm. Now PyCharm, if it is on server, it will deploy it as a server-based application, or if it is on intra-web-based cloud computing, it will deploy it as a cloud-based application. That part Python programmers will take care. You have this Python full stack programmers. They are experts in both Python and Java. Python full stack. So full stack Python programming, they don't study any statistics or anything. They purely study Python in the technical thing. So Python programming similar to Java, but a little bit lightweight. So generally we suggest people who are comfortable with Java to go for Python. Otherwise, not suggestible. And then there are a lot of technical things which you do in full stack Python, connecting to databases, connecting to clouds, connecting to IoT devices, then your function deployments, all those things, a lot of things are there. Full stack Python. Data engineering guys have to do it. So I've sent you the files. You can look into them. If you have any doubts, you can ask. So we have completed the tree-based models. We have done with the tree-based models. Tomorrow we will start with naive Bayes, not naive Bayes. support vector machines, SVMs, which are both again regression and classification models. Support vector machines, we'll understand the concept and how it will be implemented on what you call regression. SVM is predominantly used in classification. It can be done on regression data also, but predominantly it will be used in classification. Then we have KNN, k-nearest neighbors, which is a distance-based algorithm. Then we have to go through only classification algorithm called naive-Bayes. Then we have to go through regularization linear models like lasso, ridge, and elastic net. So these algorithms will go in next 2 weeks. And once we complete these algorithms, then we'll migrate into R. In R, we will do the exactly same data sets and same models what we have implemented in Python. Same data sets and same models will be implemented in R. But when you are doing in R, we'll get the statistical output. So we'll have a little bit of discussion on statistical analysis of these machine learning models. So that is what the plan for the next 2 to 3 weeks. Okay, so most probably in the next after 2 weeks, we'll get into R. Now, once we're done with R, we'll come back to Python again, where we have to complete topics like imbalance. Imbalance is both relevant to Python and also for R. We have to complete topics like regularizations, lasso, ridge, and elastic, which is relevant to both Python and R. Then we will go into time series that is relevant to both Python and R. Deep image processing, deep learning, Python and R. We'll go in step-by-step basis. So next session, we will talk about SVMs, support vector machines. So by today, I think he will give you the LMS access. I will also send him. While you're leaving, you also remind him that LMS is empty. You should get the LMS videos with the relevant data sets and projects. And then there are in LMS, you have to also clear some assignments. Whenever you find time, clear them. Okay, you have to go through the video and answer those questions. Okay, so that you complete it by the time the course ends, that LMS is also ending, because if you find midway through your course getting placed, then you will not have time for LMS, and again your certification will get stuck. It is happening with PJ17 guys. They got placed. Now they are not finding time to clear LMS until LMS and is cleared and mocks are given. They will not release the certificates. So they are working now on weekends on LMS. Some of them trying to complete those things, and the mocks also are being scheduled. And once they complete it, they'll get the certificate. And the company is also asking for certificate. You submit the certificate as soon as possible. So now they are in a hurry. So let us not get to that place. So you guys also start working on LMS. Just remind Uday when you are going that LMS access, they want the course access. Once it is done, you can start working on your LMS. Okay. So any other doubts you have, you can ask me. So you find a lot of data sets on analytics with and Kaggle. If you are interested in practicing, you can download those data sets and work upon them based on your time. right? So if you are done, you can leave.